A rainy evening in Paris in the mid-60s of the last century hardly encouraged walks, but for two men who met in the shadow of a narrow street near Le Bourget Airport, the weather was a perfect ally. One of them, a modest employee of a European aviation concern, nervously looked around, clutching a thick leather briefcase to his chest. The second, possessing the bearing of a career diplomat and a keen gaze, indicated with a short nod a car parked in the distance. That evening, not just papers changed hands, but the future of world aviation. Microfilms containing thousands of blueprints of the West's most ambitious project. This was just one of hundreds of meetings that became part of the grand mosaic, later called the greatest theft of technical secrets in the history of the 20th century. While European engineers dreamed of breaking the sound barrier, in distant Moscow they already knew what the wingspan of their common brainchild would be. In those days, the sky seemed the last frontier where political superiority could be proven not by the force of arms, but by the power of human genius. The world entered an era where time became the main resource, and speed the highest virtue. The concept of a supersonic passenger liner was not just a technical task. It was a manifesto of progress. Great Britain and France, setting aside centuries of disputes, united their efforts within the __quote_0__project, aiming to create an aircraft capable of crossing the Atlantic Ocean in just 3 hours. It was a symbol of European revival, a triumph of aerodynamics and luxury. However, on the other side of the continent, the leadership of the Soviet Union understood. To allow the West to solely own the sky meant to admit defeat in the main race of the century. Nikita Sergeyevich Khrushchev, and later Leonid Ilyich Brezhnev, demanded not just a response, but primacy, whatever the cost. Thus began an unspoken battle in which the designer's pencil was as important as the hidden camera of a spy. The creation of a supersonic aircraft faced seemingly insurmountable barriers. At speeds exceeding 2,000 kilometers per hour, the usual laws of physics seemed to cease to work. The aircraft's fuselage heated to critical temperatures, the metal expanded, and fuel drew complex circulation schemes to simultaneously serve as both energy and coolant. Western engineers from British Aircraft Corporation and Sud Aviation spent years refining the wing shape, dubbed ogival, resembling the elegant curve of a sea wave. Every line here was the result of thousands of hours of wind tunnel testing. Soviet intelligence, realizing the scale of the lag in the civilian sector, launched an operation codenamed Brunhilde. The main intelligence directorate and the KGB received a clear order to obtain everything, from the chemical composition of heat-resistant alloys to the algorithms of engine control systems. The center of this invisible war became Paris, where the design bureau working on the Concorde was located. Soviet agents, operating under the guise of trade missions and the airline Aeroflot, began a methodical infiltration into the structure of European contractors. One of the most prominent figures in this drama was Sergei Pavlov, who officially held the post of director of the Paris office of the Soviet air carrier. His charm and deep technical knowledge opened doors that remained closed to others. However, behind the facade of social conversations lay painstaking work to find vulnerabilities among European engineers. Money, ideological beliefs, or simply human vanity, everything was used. Documents went to Moscow in huge batches. Legends say that once, intelligence officers even managed to obtain samples of rubber from the runway to understand what tire compound could withstand the colossal loads during the landing of a supersonic giant. When, in 1968, just a few days before the new year, the Soviet Tu-144 aircraft first took to the skies, the world froze in astonishment. It flew 2 months earlier than its Western competitor. However, the triumph was overshadowed by whispers behind the scenes of global air shows. The external resemblance was so striking that the Western press immediately dubbed the Soviet machine Concorde. The same characteristic droop nose to provide pilot visibility, the same tailless double delta wing. It seemed that Soviet designers had simply redrawn Western blueprints. But the truth was far more complex and tragic. Possessing blueprints did not mean possessing manufacturing technologies. It turned out that Soviet industry in those years could not accurately reproduce the complex composite materials and precision electronics embedded in the Concorde project. The design bureau of Alexei Andreyevich Tupolev had to perform the impossible: adapt foreign ideas to the harsh realities of domestic factories. The internal conflict of Soviet engineers was deep and painful. On the one hand, they were top-class professionals capable of independent discoveries. On the other, political pressure demanded copying proven Western solutions to minimize risks and accelerate deadlines. This created a situation where the aircraft's form was dictated by intelligence data and its content by available resources. For example, the French __2__engines were a marvel of engineering, combining power and efficiency. Soviet designers, however, had to use engines by Nikolai Kuznetsov, which were incredibly powerful but consumed a colossal amount of fuel. To compensate for this drawback and ensure the required flight range, the aircraft's size and fuel tank volume had to be increased, which, in turn, changed the entire balance of the machine. Thus, the Concorde began to acquire its own unique and sometimes frightening features. The battle of ideas unfolded not only in design bureaus, but also in the minds of those who believed in the righteousness of their system. In the West, the Concorde was considered a commercial project that was supposed to generate profit through elite transportation. In the Soviet Union, the Tu-144 was a symbol of equality, an aircraft on which an ordinary worker could fly from Moscow to Khabarovsk in a few hours at the price of a regular ticket. This ideological paradox led to the Soviet airliner being created with an enormous margin of safety, but with less attention to comfort and cabin noise. Passengers of the Tu-144 recalled that during supersonic flight, the engine noise was so loud that one could only converse with a neighbor using notes. It was a clash of two worlds: Western individualism, striving for impeccable service, and Soviet collectivism, aiming to achieve a great goal at any cost. Tension reached its peak by the summer of 1973. The traditional Le Bourget Air Show was to be the final showdown. Both aircraft, the Concorde and the Tu-144, stood on the runway, gleaming with fresh paint and challenging each other. On June 3rd, thousands of spectators, holding their breath, watched the demonstration flight of the Soviet machine. Pilot Mikhail Kozlov, striving to show the superiority of his aircraft over its French competitor, performed a series of risky maneuvers. However, something unforeseen happened in the sky. The airliner, which was supposed to be the pride of the country, suddenly began a sharp descent, followed by an attempt to level out, which led to the destruction of the structure in the air. This event was a shock to the entire global aviation community. The tragedy in front of millions of people instantly turned triumph into catastrophe, and questions about the quality and safety of Soviet copying resurfaced with new force. The investigation into the Le Bourget incident spawned numerous conspiracy theories, which are still debated to this day. According to one version, the Soviet pilot was forced to make a sharp maneuver to avoid a collision with a French Mirage reconnaissance aircraft, which was attempting to photograph the unique forward canards of the Tu-144 in action. According to another version, there was a malfunction in the aircraft's control system, caused by an attempt to push the machine beyond its capabilities. But whatever the true reason, this moment became a point of no return. The reputation of the Tu-144 was undermined. Although the aircraft was later operated on passenger routes, its career was short-lived. After a second tragic incident during a test flight in 1978, passenger transportation was definitively ceased. The story of the ____1__ is not just a tale of industrial espionage. It is a profound drama about the limits of imitation. Soviet designers were able to copy the form but failed to fully integrate a foreign design philosophy into their production culture. The ____Tu___, despite its technical successes, ultimately faced economic realities. Huge fuel costs, bans on supersonic flights over land due to sonic boom, and high ticket prices made it a luxury toy rather than a mass mode of transportation. In the end, both projects became monuments to an era when humanity believed that speed was more important than efficiency. It turned out that a blueprint could be stolen in an evening, but to make it work for decades, something more is needed: an entire ecosystem that cannot be imitated. The perception of these events only transformed decades later. We began to understand that the Tu-144 was not simply a, quote, 3. In some aspects, it even surpassed the original. For example, the more extensive use of titanium alloys in the Soviet aircraft's design required the development of unique welding methods, which were later used in the space program. Its folding forward wings were an ingenious solution for improving controllability at low speeds, an innovation that Western engineers had not yet achieved. Thus, the process of copying paradoxically gave rise to original technical solutions. It was a painful but important learning process that showed, in the world of high technologies, one cannot simply stand on the shoulders of giants. One must be able to walk independently. The culmination of this story came when the last examples of both airliners took their places in museums. In the German city of Sinsheim, they stand side by side, as if frozen in an eternal dispute. Looking at them today, we see not only the fruits of espionage or engineering rivalry, but also the common tragedy of an unfulfilled dream of a supersonic future for all. Humanity took a step back, choosing slower but more economical and quieter wide-body aircraft. This was a moment of truth. Progress does not always move in a straight line upwards. Sometimes it requires a return to basics. The dispute over who was first and who stole what from whom lost its sharpness, giving way to the recognition that both nations aspired to the stars, even if they sometimes chose dubious paths to do so. The resonance of this story is felt even today. In an era of digital espionage and cyber warfare, the example of the Tu-144 serves as an important reminder. Today, when any information can be stolen in a matter of seconds, we are once again convinced possessing data is not equivalent to possessing knowledge. Modern companies spend billions protecting their intellectual property, but the main protection lies in the complexity of the innovation culture itself. It is impossible to steal the experience of thousands of engineers, their mistakes, their intuition, and that invisible glue that connects individual parts into a working mechanism. The history of Concorde teaches us that true leadership is impossible without authenticity. Trying to cut corners by using someone else's achievements often leads to finding yourself on a dead-end branch of development. The lessons of the past tell us that cooperation is always more productive than enmity, even if it begins with suspicion. In the late 90s of the last century, the unthinkable happened. The American space agency NASA used a modernized Tu-144 as a flying laboratory for developing the next generation of supersonic transport. American pilots and engineers spoke with admiration about the power and capabilities of the Soviet machine. At this moment, the circle closed. The aircraft, born in the shadow of espionage and political confrontation, at the twilight of its life, served the common cause of science, uniting former enemies. It was a recognition that in each of these giants there was a particle of a common human aspiration to overcome the boundaries of the possible. Today, when we look at modern blueprints of promising supersonic airliners, we see in them echoes of those very lines that were once passed from hand to hand on the rainy streets of Paris. The ghosts of Concorde and Tu-144 still hover in the design halls. We understand that those events were not just an episode of the Cold War, but a complex lesson in ethics, technology, and politics. The paradox was that, in trying to outwit each other, both sides ultimately faced the same limitations of earthly nature and economics. And this realization unites us more than any stolen secrets. Concluding our journey into that era, we find ourselves once again in that very Parisian café. The rain still taps on the glass, and two men at the corner table quietly discuss the pressure parameters in the hydraulic systems. But now we look at this scene differently. We see not just an act of betrayal or theft, but a moment of desperate search for answers to the questions that time posed to people. These people believed that their actions would change the world, and they were not mistaken, although the result was not at all what they expected. The shadow of huge wings, once covering a continent, left a deep mark on the earth, reminding us that the path to a dream is sometimes winding and full of shadows. Ultimately, the story of the Tu-144 and Concorde is a mirror reflecting our own aspiration for perfection. We learn from the mistakes of the past, understanding that the value of an idea lies not in its form, but in the path we take to bring it to life. The supersonic dream has not disappeared. It is simply waiting for its time, when new generations of engineers, inspired by the successes and tragedies of their predecessors, will once again lift us above the clouds at speeds that could only be dreamed of before. And in this new flight, there will be no place for Concordski, because each aircraft will have its own well-deserved name and its own honestly written history. The cyclical nature of history brings us back to the idea that everything in this world is interconnected. Every line on a drawing, every screw in an engine, is the result of someone's labor, hope, and sometimes risk. We continue to gaze at the sky with the same awe as people in the 60s, but now we know the price of that awe. And when the next supersonic airliner etches a white streak across the blue, in its roar, we may hear echoes of those distant events that taught us to be not just faster, but wiser. History continues, and its new chapters are being written today, based on the lessons we learned from the great confrontation in the skies of the last century. The struggle for supremacy, intelligence intrigues, and brilliant insights of designers coalesced into a single narrative of how humanity matured. We realized that technological sovereignty cannot be imitated. It can only be suffered through our own developments and tests. The Tu-144 will forever remain in memory as a symbol of the audacity and complexity of its era. as an aircraft that managed to take off against all odds and show that the boundaries between underscore underscore quote underscore zero underscore underscore and underscore underscore quote underscore one underscore underscore in the world of science are sometimes very transparent. And this transparency, despite all its dangers, ultimately pushes us forward, forcing us to seek new paths where old ones have been blocked. Concluding this narrative, it is worth once again looking at those very drawings that caused so many upheavals. Now they are just museum exhibits, yellowed pages of history. But the energy embedded in them is still alive in everyone who dreams of the sky. This energy knows no bounds and does not obey the orders of special services. It lives in humanity's striving for knowledge, which will always be above any political ambitions and intelligence operations. And it is this energy, ultimately, that is the main engine of progress, forcing us to move forward, to new horizons that are yet to be discovered. Thus concludes the story of the Concorde and its Soviet reflection. It was a story of great similarity and even greater difference, of the triumph of will and the bitterness of defeat. But above all, it is a story about people who were not afraid to dream the impossible, even if to realize this dream they had to take the most risky steps. And as long as we remember this, the sky above our heads will remain not just a space for flights, but a field of infinite possibilities for the human spirit.